Hi everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events, and this event is one of such events. If you want to find out more about the events we have, you can check the link in the description, and you will see the schedule for the coming weeks with all our events. So just go there, click on this link and register for any event you like, or you can subscribe to a Google Calendar with all the events we have. So then you don't need to sign up for individual events. Then if you haven't subscribed to our YouTube channel, the best time to do it right now. So just go under the video and click on the subscribe button, and then you'll get notified about all our new videos, and then join our amazing Slack community and to talk about different data things. During today's presentation, you can ask any question you want. There is a pinned link in the live chat. So go there, click on this and ask any question. And then at the end of the presentation, I will ask Ivan all these questions. So that's all from my side. And Ivan, the floor is yours.
All right, thank you for the intro and hello everyone. So let me try to share the screen and see if everything works as expected.
Yeah, it works.
All right, then, great. Then I will start. Again, thank you for joining. Today, I'm actually going to talk about NLP and how NLP is used in the industry. And there's a word introduction here. So my hope is it's beginner friendly as well. But if not, feel free to ask additional questions in the chat. Then let's start. What are we going to talk about today? First of all, I'm going to give you like a quick intro of what are the cool NLP projects that are out there right now. Then we're going to look at how NLP projects are built in the industry, how to hire a solid NLP team and how to manage it. And then we also look a bit into the tooling. Right, I'll just jump right into it. This is a blog post that was posted last year. It's sort of, the topic of it was about self-help, and it like wrote about how to be more productive and how to be more concentrated at work. And it gathered a lot of attention by itself. It was like on top of the hacker news. After it actually gained a lot of attention, it was revealed by the author that this whole thing was written by GPT-3. So we are already in sort of a world where it's hard to differentiate whether things are created by AI or people. So yeah, on that note, let me just quickly introduce myself. I've been in the world of NLP for quite a while. I studied computational linguistics and general linguistics, so I've been in the academia for quite some time. I also worked at 7 different companies. Right now, I'm engineering manager at Personio. Before, I worked in different roles, mainly in the data domain as a data scientist and a data engineer. Cool. So how did we get to a point where it's hard to differentiate what's written by AI and what's written by humans? So it started, NLP started a long time ago, but I'll just try to walk you through some of the bigger milestones that happened. And I think the first really big milestone would be around 97, where it was a creation of long-term short memory, so LSTMs. Was actually created here in Munich, where I'm based at the TUM by Hochreiter and Schmidhuber. And this was one of the first true AI-driven NLP applications. NLP architectures. However, back then, the hardware was just not ready to support that. And so the world of NLP has continued working on rule-based approaches using statistics and general machine learning to work on NLP. And then around 2011, we kind of moved into the world where GPUs were pretty good, where first NLP-based products started to come out, like Siri. Then another breakthrough in 2012 was AlexNet, even though not directly related to NLP, but AlexNet actually brought forward this idea of using GPUs for AI. And that really helped them establish NLP on GPUs as well. And so around 2013, that's where Google came out with word embeddings to sort of, which allowed us to really create a vector of meaning for every single word that exists there, given its context. And also LSTMs, how finally sort of could have been used by PCs back then using GPUs and were fast enough to actually be applied to different sort of industry-grade solutions. And then right after that, Siri before was more rule-based. In 2014, they switched to neural networks. That's also when Amazon Alexa came out. So AI-driven solutions have started popping up in the industry. And then another breakthrough, 2017, Google came out with Transformer, which is a neural network architecture that's based on something called self-attention. And that really propelled the AI world into what it is now. And right, we eventually started building up like higher order solutions based on the Transformer architecture, like BERT and GPT-2, which you probably heard was back then sort of OpenAI said, oh, we're not going to release GPT-2 to the world because it's just way too dangerous, way too smart, can be used for malicious intent. But eventually the community itself actually just rebuilt it based on the papers and everything that was out there. So we started using that. And then last year, of course, GPT-3 came out, massive language model that sort of split the NLP world also in two. One camp says GPT-3 has some rudimentary reasoning behind it. The other camp says it's just a very smart lookup table that has seen, it was trained on like 10% of the whole data from the internet, and it's just seen a lot of stuff and can create content out of that. Yeah, and then this year, people tried to rebuild GPT-3 because GPT-3 is a proprietary model. It was created by OpenAI and now owned by Microsoft, where Microsoft paid, or not paid, but made an investment of $1 billion into OpenAI to also own the rights to use GPT-3. But the community, again, has to get into their own hands. There's a lot of work being done on recreating GPT-3 that can be used by anyone. The models like GPT-Neo, GPT-J are out there. They are smaller version of GPT-3, but they can do a lot of things there. Just let me hide this. Yeah, so what's the future holding? Hard to say, but most probably multimodal neural networks where we combine NLP and vision together, and we get neural network models that can do both at the same time. And this graph I showed you, it's very like centralized on AI applications, but actually in the industry, rule-based approaches and regular ML are still very much used. And we will talk about why they are still useful for some problems. Right, so let's look at some cool applications that are out there now. This language model generation recently was used to transfer the brain waves into language. It's basically created by, I think, the university in San Francisco. It's using LSTMs, and it's sort of able to transfer the brain waves into actual words, which is a really cool application. And then, you have other things in the industry like Google Duplex, which basically can call a restaurant for you. It's like a chatbot that will talk to restaurant owners and actually book a place for you. And it's very convincing. It's only available in the US right now, but I think it's also coming to Europe at one point. So what else do we have? I've been also following different startups since GPT-3 came out. I think one of the interesting ones is Otherside AI. Well, basically what they do is they had this great idea, like you can answer to emails very quickly by just writing like a quick prompt, just a few lines of text. And then GPT-3 will actually generate a full-fledged, really nice business-looking email. And they, with this idea, they raised quite some funding. They actually recently pivoted into hyperwriting. Basically, it allows, the solution that they have allows you to just very quickly write articles. You write like a few words, and then the model actually finishes it for you. And it has really good results. So what else is out there? of course, OpenAI has continued working on GPT-3 and what it can do. Everyone was actually surprised that GPT-3 was eventually, initially trained to work on text, but it could actually code, which was a surprise for many people, especially OpenAI. And so what they said, hey, what if we actually spend some time into fine-tuning GPT-3 to write code? Then we'll get a really good example. And that's where OpenAI Codex came out. This is basically a derivative of GPT-3 that was trained on Python code. And it works quite well. It was recently used in a sort of competition where you could do coding challenges and you could use OpenAI as your teammate. And that was a really interesting event they had. And so also another derivative of OpenAI itself, OpenAI Codex itself is GitHub Copilot. Probably have seen some examples as well. This is then sort of a more industry application of OpenAI Codex itself. So what does GitHub Copilot can do? It can write code for you. Of course, you can just write a quick sort of documentation prompt for the function, and it will just fully write the whole thing for you. So here's an example where you write code, when you write documentation, and the rest is filled in by GitHub Copilot itself. Yeah, and it can also write documentation for you. This is a funny example I found. You start with kill all humans, and then it will actually fill in with some suggestions. So again, it's just you could say a very smart lookup table in this case, where it's trying to create code based on what it saw. And a funny fact about OpenAI Codex is it was initially trained to only work on Python, but somehow the model learned to program in other languages. I think it supports like up to 10 languages, which is quite remarkable. Right, what else NLP can do today? Right, NLP is really good at rewriting text. So here's an example. You can give like a prompt to GPT-3 and say, hey, write this sentence as if you were a lawyer. So, and you write in, a landlord didn't return the security deposit in the time allowed by California law. GPT-3 will actually write it as a lawyer. And it sounds very, very formal. Like defendant has failed to refund the plaintiff all sums of money paid within the time period specified in California law code 1950. And it actually even found the right law. So if you actually check this, this is the right California law related to sort of security deposits, which is quite remarkable as well, right? NLP can also do summarization quite well. It can do Q&A and of course text generation, which is something that we saw already. Now, how far are we in with chatbots? And that's, I think, a very separate topic. Let's look into that. There's a great idea from a company called Rasa. I think they're based in Berlin, in Germany. They are working a lot on chatbots. And they have this idea of having 5 levels of chatbots, like similar to what we have with self-driving cars. And so the first level is very basic, where you really need to write like code-based commands for the chatbot to understand you. The second level is where you actually write text and chatbot understands you, but you have to be very specific at what you are actually asking the chatbot. And so the third level is more of a contextual assistant. What does that actually mean? Is that the chatbot itself will understand context, will remember previous conversations, but again, you still have to be rather specific when talking to it to get like good results back. The level 4 is something called consultative assistance. That's when you can input very actually ambiguous queries for the chatbot, and it will still understand you. So for example, you can write, hey, I'm out of money, but my son, I need the money to finance the education of my son. Like something rather ambiguous, but the chatbot should be able to understand that and then suggest you, hey, you can take a loan here, or here's something else you can do. And at the level 5 is adaptive assistant, is when the chatbot itself is actually really smart. It can understand what you want from it, but it can also give you very specific information for very specific things. So it's like very, very smart in terms of very sort of has a really good knowledge of the domain and can work in very many domains. Right, so that's like 5 levels, but chatbots can also go bad, and there have been a few examples in the history of NLP of that. I think you probably saw Tay, but I'll just quickly run through it. What happened here? 2016, Microsoft released a chatbot on Twitter, and it allowed it to learn from the tweets that people sent to it. And that turned out to be a very bad idea, because Tay became very racist, very offensive very soon. The internet, of course, was relentless. They thought Tay to be a very bad person. And so Microsoft just really had to pull the plug, and it was shut down just within 16 hours. So if you, there is a data dump of all the tweets Tay had, and it's like 90,000 of super offensive tweets. So it's chatbots can go really wrong, really fast. So this was 2016. You'd probably have thought we have all learned from that, but apparently not. In 2020, too far. In 2020, there was another chatbot created in South Korea called Luda. So what they did is they somehow got access to 10 billion real-world conversations from something called KakaoTalk, which is basically like WhatsApp in South Korea. And based on those conversations, they trained a really smart chatbot, and was working quite well again until the internet got its hands on it. And people on the internet somehow found out a way to make it super abusive and talk about sexual themes and just really be, again, not a chatbot you want to have on production. And so, yeah, it was also shut down. And yeah, these are like 2 examples where chatbots can go really, really bad. So one learning from this is do not allow the chatbot to learn from your users, because you cannot control what the users will do with it. But there are also some nice applications of chatbots. One of my favorite projects is Project December. What can it actually do is you can write a description of a persona you want to talk to, like within a small paragraph. And you can actually, there are quite a few examples. You can describe like someone from historic figures. I've seen examples where people try to describe God and then had conversations with God, which was very interesting to see. So if you're interested, check out the examples, and lots of other things. But the headline I wrote here is that it's also chatbots like straight out of that Black Mirror episode when someone dies and they get like a replacement robot. And something like that actually happened with Project December. There was this headline actually just a few months ago where someone took Project December, they input a description of their unfortunately deceased girlfriend, and it just wrote back to the person, and it had like really good results. And the person who did this, they said it's great for them. It really helped them cope with the loss. So it's quite insane, right? It's Black Mirror. We're living in a Black Mirror episode already, right? And chatbots will continue to be developed. There's a lot of avenues for them to be developed. There's Alexa Prize, for example. It's a yearly prize that's run by Amazon, where you participate in a sort of a contest. You create a chatbot, and then anyone who uses Alexa, I think only in the US, you can ask Alexa to speak to a chatbot that was created for this competition. And then the chatbot is evaluated. Like you speak to it for about 20 minutes, and it's supposed to talk to you on like very common topics and keep up the conversation. And the second stage of this competition is there's like a panel of judges that then also speaks to the chatbot and tries to see how advanced it is. So it is not exactly a Turing test, but it's kind of a pre-Turing test where it shows you if the chatbot is actually smart enough to talk on a broad sort of array of topics. And then I also mentioned Rasa before. Rasa is a great platform for building chatbots. They have also a lot of open source solutions, and it's a good place to start when you want to build chatbots. Okay, so we talked a lot about sort of the history of NLP. We looked at what approaches are out there, what cool applications of NLP are out there, and what we can do today. So the other topic I want to also discuss is how do we build NLP projects and products? How do we build NLP and AI teams, and what tools we should use? I've been fortunate enough to manage NLP teams before in my career, and I hope the findings I have here will be helpful for you as well. So where do we start? First, you usually start with managing expectations. What expectations do we have to manage when starting to build a project in NLP or AI? Well, first of all, for managers who usually work on regular software engineering projects, it's hard to switch into AI and NLP because it's almost like a different world. Like there are things that you usually don't encounter when working in regular software engineering teams. Like you have to work with GPUs, and that's not something you do regularly. You have to know what is data annotation. How do you do data annotation properly? How do you do research, right? In software engineering, you can create a spike and then decide, oh, let's go with a solution or not. But in the AI world, and especially NLP, that's not how it's usually going to go, right? Research phases in NLP teams usually take a long time, and you have to prepare your managers for that. Now, you also need to manage expectations of clients. There are many things in play here, right? You need to figure out, hey, am I building my NLP solution only for English? Or does my client actually need additional languages? And unfortunately, these days, most of the solutions out there, open source, are still for English. And it's really hard to build something good for other languages. In my previous company where I was at, called Trust You, we actually supported 23 languages. Let me tell you, that is super hard, especially if you had to support sort of very complex languages like Japanese or Thai. So that will be a real challenge. So you have to figure that out as soon as you can. And then again, do you want to focus more on quality or coverage? Right, of course you can try to get both, but in the world of AI, that's often very hard. So check with your clients what is more important to them, a broad coverage or quality. Right, and then manage your own expectations, right? You're not going to work on the shiny new GPT-3 models all the time. Sometimes rule-based approaches are better for some problems. And even if you do, you will have to prepare yourself to be able to productionize AI. How do you bring it to the client? How do you deploy the models? This is a very hard topic. And if you're not prepared for that, it's going to be very hard for you. All right, so what is out there? Like what kind of NLP flavors can we use for our project? Well, I already talked about rule-based NLP. What is rule-based NLP actually? You write rules to work on very specific examples, right? There are pros and cons to this, of course, right? You usually need very minimal training data. You most of the time don't need any training data because you write a rule and that is just applied to the use case that you wrote it for. You also have rather minimal hardware requirements, right? You usually don't need GPUs to run rule-based approaches. And then what the cons here is that building rule sets is very time consuming, and it usually, you'll end up needing a lot of rules to cover all the cases, and that will take a lot of your time. But if you have time, the quality is actually really good sometimes. And the other pro of this is that solutions based on rule-based approaches are very much explainable, right? It's really easy to see, why did my solution predict this or that outcome? I can just go back, see the rules I have, and then say, oh, here's the rule that's actually leading to this output. And then fixing the error is usually also quite easy. You just go into the rule, fine-tune it, and then it works, right? The other approach here is sort of machine learning and statistical NLP. You usually need a lot of data for this, a lot of annotated data for it to work. The requirements here are sort of medium. You can still run ML solutions on CPUs, but you can also run them on GPUs. Where most of your time will go into feature engineering itself. So you don't need to write rules, but you need to figure out what the model should look into in order to learn, right? It usually produces also acceptable quality, but it's harder to explain, although there are quite a lot of tools available for ML explainability. And the errors are, again, not so easy to fix. You will have to look into your feature sets. You have to retrain your models and do a lot more work to fix an error compared to when you're using a rule-based NLP approach. And of course, the last one is neural NLP, AI-driven transformer models, GPT-3, all of that falls into here. You need a ton of data to make it work right. You need GPUs, very powerful ones, to make it work fast. But you don't need to spend any time feature engineering or writing any rules. Although where you spend some of your time is in something called task engineering, where you actually just have to fine-tune the model itself to be able to work for the specific task you want it to work for. Great quality, usually, but there's a downside. It tends to output unpredictable mistakes, right? And then that's usually out of your control. Like it's very hard to blacklist everything. It's very hard to test for bias and many other things. And this is the complexity you get when using neural network models. And explainability is a huge challenge as well. There's a lot of work being done to make it work better. There are some tools for sort of neural network explainability, but they're still, you could say, rather rudimentary. And errors are also very hard to fix. And you now have to have like a completely different mindset into how you fix errors, because fixing errors usually in AI models is not done through code or sort of model engineering, but it's done through data itself. You need to take your data, you need to improve it, rebalance, add more examples, add better annotation, and that's how usually you fix the errors, right? And then you need a lot of data, right? This is a funny example. If if you show the model some numbers like 1999, 1888, and then ask it to output sort of the result of 1111, it will usually, if you don't have enough data, the answer is 1121, because that's what the model saw before, and it learned that the endings of each number are en, y, and then sort of n. Yeah, so you need a ton of data to make it work right. Okay, there is sort of a subset of neural NLP that has been more brought into light, I think, last year, especially with GPT-3 out there. And it's few-shot learning, or basically the idea here is you don't really need to do anything with these big models. You don't need to gather data. You can just give a small example to the big language model, and then it will figure out what do you actually want to do. And this is a great example from using GPT-J and few-shot learning. On the top part, you see like the prompt. You would just write this as a text message for the model to read. It has 3 examples for sentiment analysis, like a message, support has been terrible for 2 weeks, and you write the output is negative. So the model actually learns by itself what you actually want from it. And then if you just leave, for the last sentence, you leave the class unfilled, like for the reactivity of your team has been amazing, thanks. The model will actually fill it in, and you see on the bottom, it fills in the positive class. And this is the only input you actually give the model. You don't really need to explain what sentiment analysis is. You don't really need to explain what you want the model to do. It will figure it out by itself, because these sort of huge transformer models have seen so many examples that they even sort of know what NLP tasks are out there and what they have to do. And they can do, many other things, do translations throughout different languages and things like that. And I think this week is also EM NLP conference. If you look at the papers, there's a lot of work also done there in few-shot learning and zero-shot learning as well. And it can also do silly things. You can ask it to create a recipe to bake a cake, and it will output you all the ingredients and even wish you to have a nice birthday. Sorry. All right. So when you know what you want to do and you sort of have an idea of how to build NLP projects, you need a team. And so where do we start here? First, you probably need a data scientist. So here's like a gamified RPG-based example of what a data scientist is. So please, I hope no one gets offended. This is very high-level, generalized example. I would say data scientists are really good at AI and ML, but not always, the best software engineers compared to regular software engineers. They are still pretty good, but it really depends on where they studied and how much experience they have. And then data scientists these days also usually are taught NLP during their AI studies, but also not to the great extent that you can solely have a data science team to work on NLP. They're also pretty good at data analysis, but they don't usually have experience with sort of ML ops, DevOps infrastructure setup. So deploying ML models, you would need a different sort of archetype or specialization. And then you have another role that has been very popular in recent years. That's the NLP engineer. So what does the NLP engineer do? Well, NLP engineer is like a data scientist, but like super specialized on natural language processing. And again, it really depends on when you actually studied NLP. So I still learned NLP when it was the rule-based approaches dominating everything. And then eventually I taught myself neural networks. And it really depends, like the NLP engineers that have probably studied the last few years only, their focus most probably was on transformer models and AI, and they maybe do not have that much experience with rule-based NLP. This is, of course, all relative. It's not necessarily the case for everyone. So yeah, NLP engineers, they build NLP pipelines. Who else do you need, right? ML engineers, right? ML engineer is also sort of a role that has emerged in the last few years. ML engineers are basically, they are pretty good at ML and programming, but their main strength is in sort of ML ops and infra and how to deploy a model to production, how to make it work. So yeah, then another sort of very specialized sort of archetype is the conversational designer. This is something I think is only started to pop up like maybe last year, this year, where you can hire a specialized person who really knows how to make chatbots be sort of human-like and really think about how does user experience for chatbot users should look like. And yeah, that's basically their specialization. Usually, from what I see, they come from like the field of applied linguistics. Yeah, and then, depending on the project, you also might need a data engineer. Data engineers are responsible for handling the data efficiently. And of course, you might need a data analyst if you want to actually present the results in a good way and maybe do some additional analysis on it. A data analyst is good to have. Right. So as I said, this is like, I don't think there's a strict separation between these sort of data role archetypes. I think you can treat them more as a specialization, right? You can specialize in multiple of these, right? You can be a good data scientist and a good ML engineer. You can be a good NLP engineer and also be a data analyst. So there's no, there are no boundaries here. Then sort of an overarching skill that I didn't mention here is domain knowledge. Domain knowledge is important. You should ideally know the domain you're working in. I think a great example is you might have, if you're following AI news, the situation at Zillow, where they had like a good data science team, but the data science team apparently did not have, and this is speculation, did not have enough domain knowledge in the financial sector. And that's why it led to a lot of layoffs and a lot of issues. So it's good to have domain knowledge that will definitely help you succeed in building the NLP projects. All right. Right, you have a team. Now you have to look at how does your team work actually. And I think there's already a difference between a development cycle of a regular software engineering team and an AI or NLP team. For software engineering, there's its own development cycle, right? You build features, you test them, deploy to production, and then you improve performance. And then you occasionally refactor what you created. But you don't go and refactor everything you wrote every month. But unfortunately, that's something you might end up doing as an AI team, right? NLP team, because there's a notion in the industry we call model health. And you deploy a model to production, and eventually the quality of it will deteriorate. And we'll talk about the reasons why this happens a bit later. But basically, for NLP teams, it's a cycle. You need to deploy models, monitor them, see how good they are, see if the data changes, then get more data, retrain model, evaluate, deploy again, and do it like, I don't know, every few months at least, to make sure you always have a sort of AI model that's up to date. All right. What else? What else do you need? I've seen data science team work well with Kanban because it's still like very research heavy work. And this is this bit of crazy idea, I would even say, by Andrew Ng of having one-day sprints for data teams. It's basically the idea is that you for example, in the NLP team, you start your day with fine-tuning the NLP model. You add some changes to it. You set up experiments, and then you just let it run through the night. Tons of experience, and then you come back in the morning. You analyze the results, and then you start over. You fine-tune hyperparameters. You change the model architecture, and then run the experiments again. And this is what a one-day sprint is. Basically, you sort of always are daily iterating on your AI model. This, as I said, it's quite extreme, but apparently it works for some teams. So if you want to try that out, feel free to do that and tell me if it was successful or not. Right, and I think for AI and especially NLP teams, it's very important to stay up to date on what's going on in the industry. But if you've done a PhD in NLP, for example, it's very, you always have like a reading group meeting every week, reading the papers, the latest papers, trying to figure out what's going on. And I think that's a key to also do in the industry, because if you don't do that, you will fall behind. And unfortunately, in the world of NLP, you get tons of new papers all the time. Like there are conferences almost every month. You get hundreds of new papers, hundreds of new ideas that you might want to try out. And so having like a set of time for learning is key here. Another thing I would really recommend, and where I had a lot of success with, is cooperating with universities, right? There's a huge talent pool there of bachelor students or master students who are just waiting to write a thesis in the industry. And I've had a lot of success with that. These very smart students can really do cutting edge research. Just make sure to pay them well. And I think you will get really great results of that. So try that out. And of course, you have to be ready to use the right tooling for your NLP projects, right? Set up the right hardware, choose the right tools. And that's something I'm gonna go into detail now. So hardware, what do you need? There are many ways to do it, right? You can, in sort of regular software engineering, now it's kind of customary to go into the cloud. But I think for AI, that's usually not always the case, right? Building a good machine with a really good GPU and putting it in the office is not really a problem. And that I see a lot of AI teams do that, especially if you have the cash to buy like a DGX machine for NVIDIA, which is like 100K. That's a good solution. But there are also options to go in the cloud, right? And for example, AWS, of course, offers GPU instances on Kubernetes and so on. And you also have a lot of other providers like, I don't know, Saturn Cloud, Databricks, and whatnot that can support you there. And there are also like a few platforms where you can do everything online. So basically, you don't need to do anything on your laptop. Basically, you just log in, you upload the data there, and then you build the code and everything else, do deployment in the tool itself. But I think it's quite dangerous. And you see here at the end, example of Floyd Hub. Unfortunately, Floyd Hub shut down in August, and they only gave like a few weeks of notice to their customers. So imagine you're a data science team who has built all of their products in one platform, and that platform tells you, hey, we're going to shut down in 3 weeks. Please refactor everything, make it work somewhere else. That's devastating for you. So don't put all of your eggs into one basket here. Right, and then choose the right software. I think if you're not doing NLP with Python, you probably should shooting yourself in the foot, because if you're using another programming languages, you're really missing out on a lot of open source projects in the domain of AI and NLP. Then I think PyTorch has become sort of more established as an NLP tool. Modern TensorFlow, you can of course argue, but if you look at the number of papers in different conferences, I think the implementations there are mostly done in PyTorch. But of course, there's nothing stopping you from using TensorFlow. And then, you have a bright array of frameworks you can use. I think that based on some surveys I saw, I think the top 3 are Spacey, Transformers from Hugging Face, and Spark NLP. So look into that. But there are also like literally more than 100 frameworks. I'll later share a resource where I list all of those frameworks and try to classify them. So that might be helpful for you. Okay, then I also promised to talk a bit about tools. And in this case, I want to talk a bit about MLOps, right? So MLOps has been sort of a new thing out there for a few years. And the idea of MLOps is to make sure you have really nice CI/CD pipeline for AI-based projects. And so I think we can, as sort of NLP practitioners, learn a lot from MLOps and apply a lot of those things to NLP as well. So what do we need? First of all, we need data versioning. You will collect a lot of data, you will change it. So it's best to really track all the changes in the versioning system. I'm going to show you an example of the tool later, right? You also want to do experiment tracking. So raise your hand if you run your experiments and then copy the results into a TXT file. I've unfortunately done that a few years ago. But fortunately enough, there are tools now that allow you to really just automatically track everything, because oftentimes you'll need to go back to your experiments that you ran, see what kind of hyperparameters you use there, and then apply them to your sort of latest model. Model registry is also good to have. What is model registry? Basically, every time you release new AI models, you will also want to store the old one. So ideally, you track all of them, which will allow you to, if your new ML model goes rogue, doesn't work anymore, or something happens with it, you can always switch back to the previous model. And if you have a good solution around model registry, that should be done very quickly. Right? Then automated testing, and especially behavioral testing for NLP. I'm going to dive deeper into that in the next few slides. Of course, model deployment and serving. You want to have a really good sort of ML engineer helping you out with the way how your model is deployed and how it can be used by your clients in an effective manner. And observability. Observability is very important for any software engineering project, but I think for AI even more important, because as I've said, there's this notion of model health, and that's something you really want to track. I'm going to show you an example of how to do that as well. All right, so where do we start? Just quickly, data and model versioning. There are quite a few tools there. I just highlighted some open source ones like data version control, DVC, or MLflow that will really allow you to, basically, it's like Git, but for data. It's relatively easy to use and will really allow you to track what kind of data changes and model changes you have. Of course, there are a lot of paid tools as well. Experiment tracking, you can also do in MLflow. There's a paid tool called Weights and Biases that's really good for this. And here is like a small link. I have all of them listed out in a GitHub repo. If you're interested, I'll share the link again later. Right, I mentioned a bit about testing. So if you're in building software engineering projects, you're probably familiar with different types of tests like unit tests, integration tests, load testing, synthetic tests, end-to-end tests, contract tests, and many, many more. I think for for NLP and AI teams, you still should have this as well. I mean, in the end, you're writing code and you want to make sure your code works right. So you should still utilize all the kinds of tests that we use for software engineering. But when you work with AI, and in this specific case with NLP, there are a few other tests that you don't really see in regular software engineering workflows. So the names here, I don't think they are so much established in the industry, but I'll try to explain what I mean by this. So evaluation validation tests. Here, of course, you always should track your sort of metrics, right? Accuracy, precision, recall, F1 score. And ideally, you have some form of test that when you release a model, you have like a held out validation test that no one has access to, and you can only see the sort of evaluation metrics. You release a model, run it on this held out set, and see the metrics. And what you can do here is that you can set up some alerts. So if you say, hey, the precision has dropped by 1%, but recall stayed the same, so it's definitely something wrong with your model. So the test should actually fail, because I don't want this new model to go to production, because apparently it's not as good as we thought it is. Then you can also have like, I call them prediction deviation tests. What I mean here is that you can have, you can take a lot of raw data, run your ML model on it, get the results, and then every time you release a new model, you can just run it again on the same test set and check how many predictions have actually changed, right? So let's say you take like 100,000 raw data samples, and then you release a new model. If you change 100 of them, then maybe that's fine. Then maybe your model can go to production. But if you change 1,000 or 2,000 of them, the predictions have changed from one model to another, and there's definitely some problem, and maybe that test should also fail. And then the third type of testing is a behavioral test. I think this is more established in the industry now, especially from last year. There have been tools like text attack, checklist out there that have been pushing for this idea of behavioral test. So what is a behavioral test? It's basically a way to make sure that your model is, first of all, not biased and sort of doesn't output gibberish. So how do you do this? Basically, with something like checklist, you can have a template and generate sort of lots of sentences based on the template. So a good example is, this is from the creators of checklist. For example, if you write a sentence, I spent a great vacation in the Bahamas, and you are testing a sentiment analysis model, and the result of this is positive, right? So that can be your template. You say, I spent a vacation, country, and had a lot of fun or something. And then checklist will actually fill in, like create 20, 30 examples with different country names and run your model on it. And then what actually happened in this particular example, they generated this, and then the text said, I spent a great vacation in Turkey, and the result of the prediction was actually negative. So why? Because apparently the model was biased for some reason, biased against Turkey itself. And if you have behavioral tests like this, you will catch sort of these biased examples before you actually go to production. So look into that. As I said, text tag, checklist, really good tools for that. Great expectations can also help with generating like raw data for the other types of tests. All right. Then I also mentioned observability, and why is this important, right? So you want to track your model health because it can deteriorate because of the model accuracy drift or data drift. So basically, the data can change, the behavioral of the users can change, and you want to make sure you can catch it early. So a great example I have from previous company I worked at, when the lockdown started during Corona times, we were working on analyzing hotel reviews, and we saw like a spike in negative sentences related to the beer category. It was really strange. When we investigated that, we saw that like Corona beer is actually a very famous beer in the USA. And what we found out is that our model just didn't know what Corona is today, right? It just thought, okay, Corona is a beer. It's not a virus. Like, how could it know? It has never seen that in the data. So having observability really helped us catch that example fast. And then we adapted the model to understand that Corona can have multiple meanings. And so, you have a lot of tools to do that. There are like specific software engineering tools, like, Datadog, but there are also specific ML tools like Pachyderm, Monte Carlo. You can do it in MLflow. So yeah, there are quite a lot of tooling around that. And yeah, the best way to monitor the quality is to have a feedback loop from the users. Like in the UI, you can allow the users to, to fix issues or just send you feedback very quickly. And that can also be a free source of training data. And it's really good to have, but do not trust the users, right? We saw really bad examples of that with Tay. Have some human in the loop check, right? You take the suggestions from the user and then have some pipeline, checking whether the suggestions are actually helpful or not. Right, and then I'm already finishing. I just wanted to say, you can follow really nice NLP startups. I think the top 3 these days are Explosion AI, creators of Spacey, Hugging Face, and Rasa. And there's like all 3 of them are open source. And I think that model works very well. And they also have paid solutions based on top of the open source solutions. So they are both giving back to the community, but also they are enterprises that are able to generate revenue. So that's if you're a startup, consider going open source. And then based on that, you can also build up some sort of enterprise solution. Okay, and then if you want to learn more, there are really great books on it too that I can recommend on sort of practical usage of NLP. Really nice ones. I think, yeah, we don't have too many books on this topic, but these 2 are really great. And I already mentioned the NLP Pandact before. I'm the maintainer of NLP Pandact. This is sort of like an awesome list, but for NLP. It right now has 1,600 stars on GitHub, so check it out. It's a huge resource of different things related to NLP, podcasts, YouTube channels, frameworks, MLOps frameworks. So if you are looking for something specific related to NLP, my hope is you will find it here. And then, yeah, this is it really. Thank you for your attention. If you want more content like this, follow me on LinkedIn. That's where I usually post on this. And I'm currently working at Personia. We're of course hiring. Right now, we don't have any NLP or AI projects, but we're looking for data engineers. For my team, I'm looking for Kotlin engineers. So if you're have any experience in that, chat me up on LinkedIn, and I'm happy to make it worth your while. Thank you.
Yeah, thanks. It was quite packed with information. Are you tired of talking, or can I ask a few questions?
Go ahead. Go ahead. As an engineering manager, I have to talk the whole day usually.
That's
so
your
got used to it.
It's a hard skill, hard requirement for engineering managers. Okay, so quite a few people were quite excited, and myself included, including about your RPG characters, these RPG cards. So there are questions like where we can get them, who created them, is it your work? Did you create them?
So the one about data science, this data scientist was created by Ines Montani. She's the founder of Explosion AI, so the Spacey people. And I basically took her idea, and I just pretty good at Photoshop myself, so I just created all the other ones. So I can actually post them separately on LinkedIn. So if you want to get the actual sort of per role slides, I can do that there. So follow me there, and I'll post it soon.
Yeah, so I already follow, so I'm looking forward to seeing this post and liking it, because that's awesome. And you said you did this in Photoshop. That's amazing.
Yeah.
I imagined how much fun you had creating these things.
It took some time, but it
they
looks
look
nice.
really nice. Yeah. Okay, we have quite a few questions. So the first question we have, that you mentioned that rule-based NLP has been in use since. So maybe let me just share my screen so
sure.
So then you'll see the questions as well. So the first question that I'm reading now is, you mentioned that rule-based NLP has been in use since early 2000. Why it is still used as current approach for NLP?
Yeah, that's a very good question. And I think especially at the time where GDPR came out, everyone was like afraid, how are we going to explain what our AI model does? And actually, this is not a problem for rule-based approaches, right? That's that's why they are still used a lot by the industry, because they are very easy to explain and they are very precise. You can get really, really high precision by engineering rules, but where you lack is in recall, right? Your coverage is not good. Like you will probably get, only a subset of predictions, but all of them will be correct, right? And that's the power of rule-based approaches. Like with AI, as I've said, it's hard to explain what AI is doing. It's also, you also have other requirements, especially if you're like a smaller startup. You don't really have enough resources to get like a really good GPU farm to work on ML experiments. Of course, you can do it now with like GPT-3 API key and so on, but it's still not easy to do. So that's why I think rule-based NLP is still prevalent in the industry. It's easy to explain, it's very precise, and it's you don't really have the requirements of hardware that you need for AI.
Yeah, thank you. And what I can add is like it's always a good idea to start with the rules and then add machine learning and other things on top of that, right? And then you can just use these things as rules. At least I don't have a lot of experience with NLP, but with usual standard ML, like this is the typical approach. Okay, so then which kind of transformer models, compression techniques are you applying prior to deployment to speed up the inference on GPU, CPUs?
Yeah, I think this is also like, it's an art in itself. There are a lot of papers on this. I think what was quite successful was like distillation, right? Where you just really reduce the number of learning parameters your model has to a point where it can still output good results, but not as good as the bigger model you had. But it's still decent enough. It's small enough to run fast. And so distillation is one approach. Of course, there's like a teacher forcing, where you train two models and one model teaches the other one, and you sort of win by doing this. The other model that is taught doesn't need to do as much work, and it's in the end much smaller. And as I said, there are like lots of other approaches to do this. If I don't know who asked this question, if you want, write to me on LinkedIn. I have some resources for this. There was a really nice presentation at EM NLP last year. I think it was from Google, exactly on this topic, where they went through like all the approaches that exist there. And I think there are also some survey papers on this that I can share.
Yeah, maybe you can send me this link and I'll just
Sure.
include this in the description of this video.
Yeah, sounds good.
Yeah. And do you know if this from GPT-3, if they talk how exactly they deployed it? Did they do some distillation there, or this is a secret? Because it's relatively fast, right? So it's not slow.
Yeah, I think it's still a secret, unfortunately, but I think, you know, they have the power of using unlimited amount of hardware, right? Because they partner up with Microsoft, and that really helps there. Of course, they probably have some techniques that we are not aware of. So
yeah, they must be doing something for speeding this up, because these transformer models, they're so slow, so heavy, right?
Yeah, I mean, I think I read something about the OpenAI Codex, where like first when they released it, like it wasn't working because there's just too much demand, and then after some time they really optimized it, and then it worked. So I wonder what they actually did there, but I don't think they actually explain it anywhere.
Yeah, maybe they just switched from PyTorch to TensorFlow. Sorry, that was a bad joke. Yeah. Okay. Maybe yeah, we have the last one. Actually, there are some questions in live chat, but we should be wrapping up anyway. Okay. So, difficult problem to solve is hate speech detection understanding. What do you think is still missing to solve it?
Yeah, there's a lot of research done in that, I think, but yeah, it's a very hard problem because it's hard to find enough examples for this, and it's also, yeah. I mean, I haven't really worked on this, so I've seen some papers on this. I mean, people also want to fix this, but I think the problem here is really not enough data, right? We need to continue collecting data and then see how we can solve this problem. But I haven't worked on it, so I don't really have any additional details here, unfortunately.
Yeah, so probably the easiest way to collect such data is just open your chatbot to Twitter and then say, hey, let's like teach me nasty stuff, and people will just generate tons of data, right?
Yeah, or just, you know, Reddit data dump.
Right. Yes, exactly. Yeah, thanks. I wanted to show you. Okay, now I have this. So I wanted to show how many people actually thanked you. So quite a few.
Thanks.
Okay, if this thing loads, but there are like many messages saying that this is an amazing session. Okay, so I need to. Yeah. But yeah, you'll have to believe me that I don't know why it's not showing up here, but in yeah,
great.
Thanks a lot, Ivan.
No problem. I'm happy to share.
That was really great.
Yeah, thanks everyone. I'm glad you liked it.
Yeah, that was packed with information, and I think like every section of your talk was useful itself, right? It could be like you just especially these data roles, I really like them, but other things was also very cool. I still have a few questions. Maybe I can follow up with you at some point later, or maybe for some other talks, I'll keep them.
Sure. Happy to do more.
Okay, thanks a lot. Thanks for joining us today. Thanks for sharing your experience with us. Thanks for sharing your knowledge with us. And also thank you everyone for joining us today, for asking questions, for being active. And have a great rest of your day.
Great, thank you. Thank you for inviting, then. See ya, everyone. Bye.
Goodbye.